question is, using the property of determinants, prove that the determinant 1x x square and so on is equal to 1 minus x cube whole square. To solve this question, we take the left hand side. On observing the determinant which is given in the left hand side, we see that if we add the elements of the first row or the second row or the third row, we get total as 1x x square. Same with row 2 and same with the third row, right? So, applying the property that C1 is changed to C1 plus C2 plus C3, I'm going to get this as 1 plus x square, 1 plus x square. Because the values are easy, so I've written directly, I've arranged and I've also written the terms in the arranged manner, right? Now, the next step is quite obvious. We are going to take 1 plus x square common from the first column. So, I'm going to get this as 1 plus x square times the determinant 1, 1, 1, x1 x square, x1. Okay, now this determinant has converted into a form which has all the three elements in one column equal to 1. So, applying R2 is changed to R2 minus R1 and R3 is changed to R3 minus R1. I'm going to get the determinant like this: 1 x square, 1 minus 1, 1 minus x minus x square. You can see from the elements of the second row, we have subtracted the elements of the first row. And similarly, from the element of the third row, 1 minus 1, x square minus x, and 1 minus x square. So I'm going to get this as equal to 1 plus x square times the determinant 1, 0, 0, x, 1 minus x, x into 1 minus x. Here I've taken x as common, so I'm going to get x into x minus 1. Here again I've taken x common, so I'm going to get 1 minus x, and this 1 minus x square can be written as 1 minus x into 1 plus x. That is on factorizing. Now, taking the determinant and rearranging this term, I'm going to get the determinant as 1 plus x square times 1, 0, 0, x, 1 minus x into 1 minus x, x square, x, 1 minus x into 1 plus x. Now you can see I can take 1 minus x common from the second row and 1 minus x common from the third row. So I'm going to get, on taking common 1 minus x common from the second and the third row, the value equal to 1 plus x square into 1 minus x into 1 minus x. And the determinant left would be 1, 0, 0, first column as it is. The second column would be x, 1 minus x, x square, x, 1 plus x. Now because the elements of the first column are such that they have two zeros, so I'm going to expand this determinant along the first column. So I'm going to get this as these terms as it is, times 1 into the determinant obtained by removing first row and first column, that is 1 x minus x, 1 plus x, plus 0 plus 0. Okay, so we do not have to worry about these zeros because 0 into any term would ultimately be 0. So both the terms in the second column are 0, so we are going to obtain 0 for the second and the third term of the expansion. Now, on solving further, I'm going to get this as equal to 1 plus x square into 1 minus x into 1 minus x, and on expanding this determinant, I'm going to get this as 1 plus x minus x square, so 1 plus x square. Now, these terms can be written as equal to 1 minus x into 1 plus x square whole square, and the term inside the bigger bracket are such that they can be written as 1 minus x cube. So this will be equal to 1 minus x cube whole square. So this is what we were required to prove, and hence the question is proved.